Our speaker today is, of course, Rodolfo Gambini, which I think you all know. He's the inventor of the loop representation, but today he's going to talk about something different, about consciousness and things like that. So the talk is quantum protopsychism and the combination problem.
Good morning. It's a great pleasure for me to be again in Baton Rouge, even it is virtually. I would like to talk today about how quantum mechanics may help to understand consciousness. I will take about half an hour because I think it's the time I need to convey the main ideas. There is growing conviction among contemporary philosophers that in addition to the information processing capacity, there is also an internal aspect of consciousness, constituted by conscious experiences ranging from mundane sounds and smells to the musical experience, which needs to be explained. The attempts to reduce conscious qualities to neurophysical functioning have failed, and consciousness is not a publicly observable phenomenon like any other physical one. It is considered that the problem of explaining these phenomenal qualities, like the perception of a seascape, where visual, auditory, tactile, and olfactory qualities are combined in a structured world, is the hard part of the problem of consciousness. Physics describes structures and processes. It does not explain how sensible qualities arise from them. However, a theory of consciousness should at least identify the physical counterpart of phenomenal properties like perceptions and volitions. An approach proposed centuries ago that has returned with great force in recent decades is the panpsychist approach. As we'll see, is not free from problems, one of the most important being the so-called combination problem. I would like to show here that the kinematical properties of quantum mechanics allow us to solve the problem that is considered as the main difficulty of the panpsychist approach. In what follows, I will analyze the limits imposed by the physical description of the world. I will introduce a form of panpsychism consistent with the action of quantum mechanics. I will analyze the criticism to which panpsychism has been subject, like the so-called combination problem, and I will propose a solution to the different aspects of this problem. I will start by discussing the mathematical representation of the world provided by physics. The structuralist conception of science shared by many philosophers such as Russell, Wittgenstein, Van Fraassen, and physicists such as Mach, Hertz, Poincaré, Planck, and many contemporaries distinguish between the mathematical laws and the world they describe. It considers that the physical description results from a process of abstraction and idealization. Starting from real objects, those that are correlates of observable phenomena that are not necessarily mathematical in their intrinsic nature, we attribute them through measurements mathematical properties. An example would be the location of the planets on the celestial sphere as seen from Earth, from the perspective that the phenomena offer an empirical mathematical description is constructed, like the Copernicans, summarized in part by Kepler's laws, using carefully collected astronomical data. The theoretical work that remains to be done is to deduce the empirical mathematical structure given in Kepler's laws from a model of the solar system and the law of dynamics. Physics then begins by describing certain phenomena to which we associate mathematical properties through measurements. Structuralism does not assume that the world is exhausted by the physical description. It only considers that the regularities that physics identifies in its description of processes and phenomena are fulfilled without exception. I will adopt this view of the physical laws here. Pan-protopsychism is the thesis that fundamental physical entities have elements like the mental ones. The idea dates back to ancient times, and forms of panpsychism were also postulated in modern times with Spinoza's parallelism or the monadic vision of Leibniz. It was taken up with particular interest in the beginning of the 20th century by William James, Alfred North Whitehead, and Bertrand Russell, and recently by Galen Strawson and David Chalmers, among many others. Bertrand Russell is a scientific structuralist in the sense I mentioned above, and a panpsychist. He shares the view that physics only describes structures and causal connections, and that the matter in a given place is all the events that are there, and goes on to say that such a view of matter implies that we no longer have to deal with what used to be mysterious in the causal theory of perception, how a series of light of sounds waves suddenly produce a mental event apparently totally different from them in character. For Russell and the so-called neutral monism, the physical and the protopsychic will be nothing more than two ways of approaching the same object, the event. An ontology of events, like the one proposed by Russell based on quantum mechanics, would provide the following interpretation. Events in the external world are described by physics, but they are not necessarily exhausted by this description, having an internal experiential aspect. At least some events in our brain could be directly accessible as perceptions of qualia. The main difference lies in the way we access events. First-person access for the mental and third-person access for the physical. Sometimes something similar could occur with states. The process of detecting photons by dissociation of silver bromide on a photographic plate, which gives rise to a cascade effect that produces the accumulation of millions of silver atoms, is an example of the production of an event by a quantum object, the appearance of a dot on the photographic plate. All measurements are about the properties of some event. As noticed by Strawson, the common belief that conscious experiences are basically inexplicable in physical terms result from the assumption that the physical is in itself something fundamentally non-experiential in nature. For panpsychists like Russell or Strawson, the intrinsic nature of the physical is experiential. As we will explain in what follows, we consider that a quantum form of panpsychism is required. The actions of quantum mechanics refers to the primitive concepts such as systems, states, events, and the properties that characterize them. Each of them have a mathematical description. Based on this ontology, systems in certain states and events can be considered the building blocks of reality. Events are the ostensible entities. We assign mathematical properties to them through measurements. The states characterize the dispositions to produce events. The dispositions of states are objective properties, and the states have the same ontological status than events. The disposition to produce events are the probability amplitudes of obtaining outcomes for an arbitrary set of compatible measurements. Today, we know that many biological phenomena can only be explained in quantum terms. For instance, while many aspects of photosynthesis can be understood using classical biochemistry, the extraordinary efficiency of the energy transfer requires quantum mechanical explanations. Nowadays, several hundreds of papers about quantum biology appear each year. In our opinion, quantum mechanics should play a fundamental role for the understanding of conscious phenomena. Let me now discuss the combination problems of panprotopsychism. The most difficult problem facing panpsychism is the combination problem. This term comes from William Seeger, but the problem goes back to William James. It refers to how we explain the emergence of complete minds by assuming that their elementary components have protopsychic or experiential aspects. The problem was raised by William James as follows. When the elemental units which compose complex minds are supposed to be feelings, take 100 of them, shuffle them, and pack them so as close as you can, whatever that may be. Still, each remains the same feeling it always was, shut in its own skin, windowless, ignorant of what the other feelings are and mean. Private minds do not agglomerate into a higher compound mind. In other words, James thinks that, as in the classical physics, the properties of the parts remain invariable in the whole, and that the properties of the whole are nothing more than the functions of the properties of the parts. They are determined by them. Therefore, it is hard to see how proto-minds agglomerate into a higher mind. The classical physicalist program is to explain consciousness in terms of supervenience. According to supervenience, two classical complex systems are equal if their parts and the relationships between them are also equal. This is what happens in a classical system of particles. Any property of the system is a function of the properties, the position and momenta of each of the particles. The notion of supervenience is used extensively in philosophy as if it were universally valid, but is totally inadequate when it comes to quantum objects. Simplifying, most panpsychists think as follows. The fundamental particles that compose the brain have mind-like properties. As the brain is composed by these particles, this would explain the phenomenal aspect of our mind. The problem is that they implicitly think that these particles behave classically, and therefore the combination problem arises. Chalmers has analyzed the form that the combination problem takes in the panpsychist approach, identifying three sub-problems based on different aspects of phenomenal consciousness. Yes. The subject combination problem deals with how microscopic proto-subjects. Please tell me if you have a question.
No, sorry, there was just noise outside.
Okay. The subject combination problems deals with how microscopic proto-subjects combine without leaving traces of its components to give rise to macroscopic subjects like us. The quality combination problems deals with how do the extremely rich and varied qualities provided by the sense organs, a certain shade of red, for instance, or the sounds emitted by the different instruments of an orchestra, of the rich variety of perfumes, emerge from some few basic physical properties such as those of the particles that intervene to produce them. Seeger sums it up as follows: how it is possible for the richly painted canvas of human experiences to be produced from such a small palette of paints. The structure combination problem results from the observation that human experience is rich not only in qualities, but also in structure. Our perceptions present a structure that includes optical, auditory, and kinesthetic fields organized spatially into an integrated whole. But the microphysical structure in the brain seems entirely different from the macrophenomenal structure we experience. Microexperiences presumably have a structure closely corresponding to microphysical structures. And we might expect a combination of them to yield something akin to macrophysical structure like a firing patterns of neurons. How do these combine to produce a macrophenomenal structure instead, like the ones we experience contemplating a landscape? In other words, the macrophenomenal structure has nothing to do with a set of neuron firings. And if you take the panpsychist point of view, it should correspond in some way to this pattern of firings. These problems arise from the use of a classical notion of supervenience, which states that properties of the world result from those of its parts and the relationships between them. Let me now discuss briefly why quantum mechanics may help to solve this problem. Thanks to the superposition principle in quantum kinematics, there is a form of emergence that changes the way we understand the problem. In quantum mechanics, the properties and states of the world do not supervene on the properties and states of its parts or its relationships. This occurs in entangled systems, that is, in most quantum systems. For instance, in the system of two electrons in the triplet or singlet state, I'm considering here the triplet state, it is not possible to assign a defined spin orientation with probability 1 to each of the particles that compose the state. It doesn't matter in which direction we measure the spin of one of the particles, half the time it will be up and half the time it will be down, while the spin of the total system is well defined. The total spin of the system is completely defined. It will be equal to 1 with a component along z equal to 0. The total system has properties, the z component of the spin, that do not result from the properties of its parts. In fact, its part has not property corresponding to components of the spin. In quantum mechanics, there is what Teller and Hiller call physical property holism. It says that in quantum mechanics, there are physical systems whose physical properties and relations do not supervene on properties and relations of the parts. This behavior of systems in entangled states allows to have emergent properties that cannot be explained in terms of properties of its parts. This issue has been discussed in many papers. I mentioned here some reference. Most of the properties of the particles of the total system disappear due to entanglement. The number of emergent properties that the total system can have that does not supervene on the properties of its parts grows exponentially with the number of parts. For example, a system of n entangled spin particles can be in states which depend on 2 to the n arbitrary coefficients with different properties of the total system and different dispositional states, or causal powers to produce events in other systems. According to quantum mechanics, physical reality cannot be understood as the sum of its parts in conjunction with the spatiotemporal relationships between the parts. The intrinsic properties of entangled systems do not supervene on any intrinsic or relational properties of the parts, taken separately. In fact, the parts may not have any well-defined property. This is the characteristics that allows quantum theory solving the objections raised by the combination problem of panpsychism. Note that this property of quantum mechanics results from its kinematics and is totally independent of the interpretation we adopt about the problem of measurement. Let me now discuss a couple of problems of combination. We will start with the quality combination problem. If classical ontology were applicable, we could only expect a handful of micro-qualities corresponding to a handful of fundamental microphysical properties associated with the different elementary particles of fundamental components. How can this limited palette of micro-qualities be combined to produce the vast array of macro-qualities, like the various shades of colors or the sounds emitted by the instrument of an orchestra? In particular, how do the properties of the elemental system that combine to produce those qualities are not observable? Here, the prejudice resulting from classical physics that generate this problem clearly appear. In fact, the properties of the world are again supposed to come from those of its parts and therefore grow linearly with their number. If some type of quantum interface in an entangled state existed in the brain, whose states and events characterize its experiential properties, it could provide an exponential number of new states, while its parts would cease to have most of their properties and lose individuality. This would give a satisfactory and intelligible answer to the palette problem and a good part of the combination problems. Returning to Seeger's metaphor, quantum mechanics give us an exponentially large palette of colors to produce the richly painted canvases of human experiences. Certainly, the information processing would be generated by neural functioning. The complex neuronal structuring will not leave a trace in the perceptions that would be associated with a coupled quantum system. In quantum models, consciousness is not directly associated with the network of neuronal excitations, but with a quantum system composed of many microscopic components. For instance, Posner molecules with nuclear spins that interact magnetically, as in Fisher's model, in entangled states that extend across macroscopic regions of the brain and are capable of interacting with the neural system, in particular with the synaptic clefts. Posner molecules are compounds of calcium and phosphates, and are molecules that can protect qubits from decoherence. The spins are nuclear spins in phosphorus nuclei, and they are protected by decoherence because these molecules have a behavior, vibrational behavior that keeps the spin of the nuclei for several minutes. And these objects could play the role of a working quantum memory. Our phenomenal life would emerge from this kind of molecular quantum system. Other photon-based mechanisms have also been proposed. This proposal was done in 2015 by Fisher, and it is still considered as one of the most interesting quantum proposals for the description of the consciousness. Here it is not necessary to take this particular suggestion, but only take into account that some kind of quantum interface is necessary. I will now discuss the structure combination problem. Perceptions have informational content. Perceptions give us the only immediate insight concerning reality, something which can never be obtained from conceptual or logical means. Our perceptions are not only rich in qualities, but also in structure. The wealth of our perception and their organization is in complex spatial or temporal representations that combine data from different senses seem to be very different from the structure of the neural organization. A particular pressing aspect of the structure problem, called the granularity problem, is the concern that the experiences appear fluid and continuous in a way that is at odds with the discrete and particularized structure of the neurological properties of the brain. How did the psychic correlates of this set of electrical discharge and signals combine to produce a macrophenomenal structure? The problem of granularity would not arise in our model, since the entangled quantum system would only have, as we saw, global properties. There is, however, a second aspect of the problem of the structure. Our macro experiences have a rich structure which involves the complex spatial organization of the visual, auditory, and the other senses. How can micro experiences lead to the rich structure of the perceptions and its strong informative content? If this informative capacity of perceptions was developed due to Darwinian evolution, some form of efficacy of the phenomenal contents is needed to ensure that they can influence in the ability to adapt. In recent decades, the conviction has increased that consciousness extends to a good part of the animals, and there are multiple examples of the evolution of our perceptive abilities. In a declaration signed by hundreds of cognitivists, neurophysiologists, and philosophers in 2012, it is stated that the absence of a neocortex does not appear to preclude an organism from experiencing affective states. Convergent evidence indicates that non-human animals have the neuroanatomical, neurochemical, and neurophysiological substrates of conscious states, along with the capacity to exhibit intentional behaviors. Consequently, the weight of evidence indicates that humans are not unique in possessing the neurological substrates that generate consciousness. Non-human animals, including all mammals and birds and many other creatures, including octopuses, also possess these neurological substrates. Animal behavior is completely based on the information that results from the perceptions without involving any conceptual analysis. Perceptions become richer and more informative as we ascend the evolutionary ladder. In a Darwinian context, this requires that the phenomenal contents of the perceptions provide adaptive difference that allow natural selection to operate. In classical physics, that kind of physical phenomenal interaction would be impossible due to the causal closure of classical physics. In fact, in classical physics, any effect results from a cause that is also physical. In fact, interactions between the nervous system and its phenomenal counterpart would be necessary. The causal openness of quantum mechanics due to the indeterminism would allow such interactions. In a quantum system like the one suggested above, the phenomenon would affect the physical through the selection of events of neural discharge in the interaction of the quantum state with the neural network that would function as a measuring device. I will not discuss the last combination problem because I wanted to take only half an hour. The subset combination problem was discussed in our most recent paper that was published in the Journal of Consciousness Studies. And is based on ideas of the nature of the subjective experience due to Whitehead. I will go directly to the conclusions. Quantum kinematics implies the emergence of causal properties and capabilities associated with entangled states without leaving a trace of the properties and capabilities of the parts. This, together with the causal opening of quantum systems, typical of probabilistic behaviors, allow us to give satisfactory answers to the different combination problems of panpsychism. Is experimental evidence emerges of quantum phenomena in the brain that allow the appearance of robust entangled states coupled to neuronal discharges, some form of Russellian-like protopsychism would be extremely plausible. This would require a deep revision of our contemporary conception of reality. It would be necessary to rethink the dominant conception of the world resulting from the last centuries of scientific activity, incorporating the centrality that conscious phenomena seems to have. This does not mean abandoning any physical result, but rather abandoning the stereotype noted by C.P. Snow that possesses an irreconcilable bifurcation between the sciences and the humanities. Conscious life would then not be a marginal result, but a central product of the development of the universe. Okay, I will stay here. Thank you.
Any questions? Come on, it's your chance. You asked for this talk.
I think you're gonna speak first.
Hi, Rodolfo.
Hi.
This is Ivan. Good to see you.
Yes, good to see you also.
Miguel, my friend, how are you?
Hi, Ivan.
Thank you for the talk. I mean, I have many questions, but I need to put them in in order. So
Okay.
they are. One is that it seems to me that you know, the main feature of quantum mechanics that you have used has more to do with correlations between different parts of the system, right? Of course, if you work with a pure state, correlations translate to entanglement, but
Right.
in general, you know, this fact that there are many more numbers characterizing a state than the number of constituents is because there are correlations between different parts of the state. And that is why...
I'm
Go
sorry.
ahead.
No, you may think that simply in this way. In order to define an entangled state, or composed, let's say, for n spinning particles, you need 2 to the n independent coefficients.
Right, exactly. And then that is because I mean, one way of thinking about that.
And this leads to an enormous variety of correlations, yes?
Exactly. And are these correlations that make the whole much more than the collection of individuals? But my question
I
is,
have yes.
my question is that correlations can also be can also happen in classical systems. So it seems to me that if we are just invoking correlations, why you only invoke quantum correlations and not a more general family of correlations taking place also classically?
I am taking a different point of view. I am taking the point of view that the fundamental objects of these quantum systems are the events and the states. The states defined in the form that I mentioned above as disposition to produce events. In this sense, I consider that the consciousness is directly related with the state of the system, the entangled state in this case. But it is an access of this state from the inside, let's say, and not from outside. It is not an objective, but a subjective access to the states. And this kind of access to the state is completely unique of consciousness, because it is impossible to simply determine an state with individual measurements, and therefore externally you need statistical procedures in order to recognize an state.
Right. What I don't understand, and that is my question is why rather than using quantum entanglement, you don't want to use classical correlations to produce something more than the combination of individual parts?
I think that classical correlations play a fundamental role, because classical correlations would be the manifestation of this entanglement in the neuronal system.
Right, but then why do we really need
the neuronal system plays the role of measuring device, and is the way that this subjective state interacts with the brain.
Right, but why are not classical correlations alone sufficient? You can understand entanglement as a specific subfamily of correlations if you want those that violate Bell inequalities, but there are more correlations in nature which are, we call them classical. Why they are insufficient to explain consciousness?
I think that it is because the combination problem implies this independence of its parts. If you have correlations, you still have the parts.
And is not that the case also with entanglement, that you still need the parts to be entangled with each other?
No. I have shown this in this example. If you consider an entangled system, you may not have any properties of the component particles of the system. You will have always will have properties of the whole, but not always you will have properties of the parts.
Right. I was thinking that's a good point, because I was thinking about that example of two spin 1/2 particles prepared in a singlet state, and I was thinking in a classical random state, in a probability distribution of two particles with angular momentum 1/2, if you want, which are produced in pairs with each of them with random angular momentum, but always the total has, let's say, 0 angular momentum. So, you know, the classical analog of a singlet state. So I don't know if I am explaining myself. I have an apparatus measuring, you know, creating pairs of particles such that the sum of the angular momentum is always 0, even though the individual angular momenta are randomly created. That to me is an example where the individuals do not have.
Yes, I suppose you agree that this is different from what you have from entangled states, because in particular, this will not violate the Bell inequalities.
Correct. That's correct. That's correct. That will not. That is my question.
Okay.
You know,
there are different things. I cannot say if this kind of correlations will appear and if they are sufficient. What I showing here is that if you start from this quantum scenario, you may explain the combination problem. And if you are able to discover this kind of quantum scenario, you will have a version of panpsychism that would be compatible with or will free from the problems of combination.
I see. You are just arguing that quantum entanglement is a possibility, although there could be other possibilities.
Yes.
Thank you. Thank you.
So what I guess what Ivan is asking is, why do you need correlations that violate Bell inequalities to do all this? Why can't you do it with classical correlation?
No, there is a different reason for considering quantum states that I mentioned when I discussed the structure combination problem. And it is that if you don't have these kind of correlations, it is impossible to have interactions between the phenomenal, the conscious realm and the physical realm, because the physical realm is closed. That is, any physical effect has a physical cause. And therefore, why this structuring of the perceptions that is the basis of the orientation of animals and the recognition of the world of animals has evolved in time and was effective in evolution, in particular in Darwinian evolution, how these properties would have any effect if you have a classical world.
Yes.
I mean, I guess the statement is that the classical world is closed and therefore doesn't have any opening for consciousness.
But the classical world is the whole universe, so there could be correlations between subsystems within the whole universe and give rise to local consciousness.
But even in this case, it is closed. I need to explain how, why a kind of properties that are qualitative as the conscious properties are able to produce an evolution, a modification of the organization of the brain.
I see. Okay, thank you. I mean, I am just trying to understand the point, the viewpoint. There was a lot of information in the talk that I need to show.
More questions?
Yes, sir.
Go ahead.
Hi, thank you. There is any way to try to test these ideas? I mean, any way to test if, I mean, this has like some, well, I mean,
Yes,
just want to test these things. Thank you.
yes. This is related with the problem of quantum biology. Quantum biology, that is, as I said, it is developing very quickly. In fact, at the moment, there is not an explicit test of a quantum effect in any biological system. What there are an enormous number of quantum mechanisms that are the only able to explain the effectiveness of some processes as photosynthesis or explain the orientation of the birds and for instance, the recognition of different smells. All these processes are related with, are explained in quantum mechanical terms, but an explicit verification is not available up to now.
Thank you.
And then this is not very strange because it is, there are very fragile, the quantum phenomena, and but the mechanism, for instance, for recognition of smell, is very simple and nice, and indirectly has been verified. That is that the smell receptors are able to recognize the vibrational behavior of the molecules. The vibrational behavior of the electrons in a molecule. And this is a quantum effect that requires a quantum kind of excitations.
Thank you.
I have a question. What do you mean by the causal opening of quantum systems? Because you talked earlier about how classical systems are causally closed. So why are you considering that quantum systems are causally open?
I am considering that quantum systems are causally open because when you observe an outcome in a measurement, in principle, this outcome is not related with any cause. It's simply the result of a random process.
Okay.
More questions? All right, shall we thank Rodolfo again?
No, there's another question.
I was gonna ask one thing. So experimentally generating and maintaining entanglement is usually very, very difficult and kind of fragile. Do you think that the brain would be a suitable environment to generate entangled states or to host them for this?
Yes, this is a very important point because with ordinary matter, the coherence time is very short. It's not enough to. Consciousness take a fraction of a second, half a second, or something like that. and the coherence may occur in microseconds or picoseconds. And therefore, for most of the systems, the coherence will destroy coherence, and this kind of process is not possible. This is the reason because the search is concentrated in certain systems. In particular, there are two kinds of systems that have been considered. One is related with entangled photons, and this has been observed recently in the brain. And the other is related with entangled nuclear spins. The nuclear spins are more resistant because the nuclei are very far from everything, but they interact electrically and magnetically, and therefore you need some mechanism for protecting these interactions, and this mechanism is provided in this case by the Posner molecules. And there is literature on this subject estimating the coherence time. And in principle, there is certain agreement that it requires a time of the order of the minute or several seconds.
Thank you.
Any other questions? Miguel? Anyone else in the room?
Maybe, okay, I can ask one crazy. So, Rodolfo, so I guess this artificial intelligence as it stands, according to you, could not acquire consciousness if it's run on a classical computer. And I don't know, do you have any comment on artificial intelligence and maybe in the future operating it with quantum computers and acquiring consciousness?
Well, there have been recently proposals about this subject. Penrose is always thinking in this problem, and he has proposed the idea that probably it is possible to create consciousness in a quantum computer. I don't think so, because as I explained, you need to develop a computational system that is able to enhance the quantum capacities. And this is the mechanism was the adaptative change introduced by the phenomenal properties. I don't see that may be produced by the outside from, I don't know, from some idea of how this sensibility to the phenomenal would be created. But it is simply an opinion.
Thank you.
I mean, there actually even is a startup company in Canada that is claiming that they're going to build an artificial intelligence that is conscious by coupling it to a quantum system. So it's a private company, so.
Glad for them.
All right, I think people in this group have another meeting in 5 minutes. So is there any other questions?
Okay.
You were saying, Rodolfo?
No. I am.
Okay, let's start, Rodolfo, again.
Thank you.